Okay, let's talk about dummy variables. Let's take a look at the data set. In our data set, we have a very particular column called state. It records from which state a customer comes from, right? We have TX to represent Texas, CA to represent California, NY to represent New York City. Yeah. This column is different from incomes and gym visits, right? When we build a relationship between incomes, gym visits, and hours, we can say the more incomes a customer has, the more frequent the customer visits the gym, the longer she will use the mobile app. But if you consider which state the customer comes from into your mathematical model, it's very difficult for you to say the longer state she comes from, the longer she will use the mobile app, right? Yeah. This column, the state column, the values in this column, doesn't measure how long, how large, how big, right? Yeah. It just indicates a category, which state this customer comes from. If you have values, they play a role as a label to indicate different categories, different types, different states. We call those values categorical data. Categorical data. As you can see here, they are called categorical data. Other typical examples of categorical data in data analysis include gender, right? You cannot say how long the gender is, how big the gender is. You can only say female group, male group, right? Gender just plays a role as a label to indicate from different group the customer comes from. Educational level is another good example of categorical data. We have freshman, sophomore, junior, senior, grad students, right? Yeah. They don't measure the data value. They indicate from which group this student comes from. Another example is state, as you can see in this data set. State. Let's take a look at how many states these 100 samples come from. Click the State tab, and then click the Data tab on the top. And then in the middle, you should be able to see Filter, right? Click Filter. Oh, let's do this. Let's save this data file into a new data file. We don't want to mess up the original data set. Let's click File, and then click Save As. Save As. Let's create a new data file. Let's call this Fitness App Dummy Variables. I will talk about dummy variable concept later tonight. Dummy variables. And then save this file into the desktop. And then click the State tab. Click C1. And then click Data tab on the top. And then turn on the Filter button. Click on Filter. And then in your title row, you should be able to see some upside down little triangles show up, right? Yeah. These are called filters. They can rank data according to some criteria. We want to see how many states this 100 customer come from. So let's click the little triangle in State. And then choose Sort A to Z. Now you can see which states each customer come from, right? CA, California, 1 state, right? MD, Maryland, 2 states. ND, North Dakota, 3 states. NY, New York, 4 states, right? Scroll down, SD, South Dakota, 5 states. TX, obviously Texas, right? 6. And then WA, Washington. State of Washington. So totally we have 7 states, 7 categories, right? Categories. How should we consider these 7 states? How can we say which state the customer comes from influences how long the user will use the mobile app? This is what we want to do. Remember, we have 7 states, right? In other words, 7 categories. Let's build some new columns. First, we want to build state CA. In E1, we want to type in state CA. Next, if a customer is from California, we use value 1 to indicate she's from California. Yeah. So you look at E2. If the value in E2, in C2 is CA, then you type in a 1. Obviously, you can drag the autofill button to all CA, right? Until E21. That's the last customer from California. We use value 0 to indicate a customer is not from California. Obviously, you can type in 0 in cell E22 and then drag the autofill button of E22 to the last cell, to E101. Right? Any question? Muthu? You have a question? No question, right? Yeah. 1 to represent this customer is from California. 0 to represent all other states, no matter Texas, New York, or Washington. We use 0 to represent them all. Next, we want to create the second category. The second one will be MD, right? In F1, let's type in state MD. Same thing. We use 1 to indicate a customer is from Maryland. 0 if the customer is not from Maryland. What should be the value in F2? 0, because she's from California, right? And then in cell F22, what should be the value? 1. Very good. And then drag the autofill button to F31. What about F32? 0. Yes. She's not from California. She's from not Maryland. Where is she from? North Dakota, right? ND. The third state is North Dakota, ND. So in G1, we want to type in state ND. We use 1 to indicate the customer is from North Dakota. 0 if she's not from North Dakota. What should be the value of G2? 0, because she's from California, right? Yeah. And then drag the autofill button to G31. From G32, we type in 1 and then drag the autofill button to G41. What about G42? 0, right? Okay. Next, we want to create the other state, state NY. Type 0 to H2, and then drag the autofill button of H2 to H41. And then in H42, type in 1. And then 1 to H51. You look at the C column, right? To indicate if you should use 1 or 0 for the H column, G column, F column, and E column. If she's from NY, we use 1. Source Dakota should be 0. State NY. Next, state SD, South Dakota. And then in I-52, we should use 1 because she's from South Dakota, as you can see in the C column. And then drag the autofill button to I-61. And then 0, continue. South Dakota. Next, state TX. If she's from TX, 1, otherwise 0. TX. Well, Texas is a very important market now. Yeah, you must consider Texas market. If you see some truck commercials, they have a Texas edition. That means Texas customers have a lot of buying powers. Yeah, so big that they create a Texas edition. Yeah, that's very cool. So we have state CA, state MD, state ND, state NY, state SD, state TX. This is how we indicate from which state the customer is from, right? Muthu has a question. What about the state WA, state Washington? Do we need to create a column called state Washington?
It's implied.
Do we have to? You can, but we don't have to. Why? Because we checked the other 6 columns we just created. Yeah, we check if the customer has 1 or 0. If the customer from Washington, she will get all zeros in the previous 6 columns, right? Yeah. For the simplicity purpose, we don't have to create a new column called state WA to show the customer is from Washington. There is a logical connection between the previous 6 columns and the state Washington. Yeah. We don't have to label it. The analysis? The analysis, I will explain. Very good question. Yeah.
So could we have had a logical conclusion from just 2 states instead of having all at least 5? We could have made like a logical connection from 2. If you're saying since from 5 states, the logical conclusion has been made already.
Yeah.
So we don't need to add that.
It depends. It depends. In our case, we want to analyze each state influence on the hours. If you only look at, let's say, Texas market, if you only want to say if Texas is an influential factor, which means you want to compare the customer from Texas and the customer from non-Texas states, then you only need to create 1 column. Yeah. All customers from Texas get 1 as a value. Otherwise, they get 0, right? In this case, we want to compare all 7 states. That's why we want to create how many? 6 columns. Yeah. Actually, Ada just asked a very good question. If I want to compare 2 groups, 2 categories, how many categories we create? Just 1. Yeah. If the customer is from Texas, she gets 1, right, in the column. Otherwise, she gets 0 in the column. If we want to compare two groups, we create one column, right? Yeah. This one column has two different values. If we want to compare 7 categories, 7 states, how many columns we just created? 6. Yeah. So if you want to analyze the values, the categorical values influence on your dependent variable, first you want to look at how many categories you have in your data set. In our case, we have 7 states, right? 7 categories. So the number of categories is 7. Then you can decide how many columns you create to analyze the influence. How many did we create? 6. You can find the relationship between the number of categories in your data set and the number of columns you created in your data set. Let's say we use letter C to represent the number of categories. We use the number D to represent the number of columns you create to analyze the influence of the categories. What is the mathematical relationship between C and D? D equals to C minus 1. Yeah. But we cannot call 6 columns, right? That is for high school students. We cannot say we create 6 columns. We have to differentiate them. We call state CA, state MD, state ND, state NY, state SD, state TX, dummy variables. Dummy variables. As you can see here, dummy variables. They are called dummy variables. Then you can make a conclusion between the relationship of the number of categories and the number of dummy variables you need. D equals to C minus 1. Yeah. When you move to more advanced analysis, when you study other software like Python, R, those kind of software, you don't have to create 6 columns to represent those dummy variables. Those higher level software is able to differentiate the categories automatically. But we are using Excel in this class. The limitation of Excel is it cannot understand symbols. In our case, the original data set, for state column, we use symbols to represent which state this customer is from, right? The limitation is Excel cannot understand symbols like CA, TX, SD, ND. That's why we have to create 6 dummy variables. We use 1 to indicate this customer is from a particular state, 0 to represent this customer is not from a particular state, the state of interest. That's the reason. When you move to advanced data analysis, you don't have to create the 6 new dummy variables as we just did. But if you want to analyze the categorical data's influence on your dependent variable in Excel, you must create the dummy variables like the one I just showed. Yeah. Because most of the companies are using Excel in their data management, we have to get to know how we process dummy variables, categorical data in Excel. That's the reason. Let's take a look at the influence. How can we analyze the dummy variable's influence? Let's say in our new analysis, we want to analyze income's influence, gym visits, which state this customer is from. 3 factors. How they influence ours. This is what we do. click Data tab on the top. And then click Data Analysis. Oh, before that, we have to change the order of the data set. Because Excel specifies that the independent variable must be adjacent to each other. You cannot separate the independent variables. The independent variable columns must be together. They are in a contiguous range. So let's change the order. First, let's select the D column. This is the dependent variable column, right? Select D and then right-click on D, and then choose Cut. And then move D to, let's say, use K. Right-click on K and then Insert Cut Cells. And then select, we can turn off the filter button. Then select State. As I said, Excel cannot process symbols, right? So we have to cut it off. Right-click on C column, and then choose Cut. And then go to K, and then Insert Cut Cells. So you should have this new order before you perform the analysis. And then click the Data tab. And then click Data Analysis. You should be very familiar to this one now, right? Regression option. Regression, and then click OK. For the Y range, we need to choose dependent variables. What is it? Hours. Very good. Let's select I1 to I101. This is the dependent variable range. So you should have I1, I101. Click the button on the right to confirm. For the X range, we need to select A1 to H101. All of them. Yeah. Incomes, gym visits, where they are from. As you can see, we just did a transformation, right? We transformed the value in the J column to the values in C, D, E, F, G, and H. Select all of them from A1 to H101. Same thing, we check the box before labels, before confidence level, select a new workbook, and then check the box before residual plots. And then click OK. We'll talk about the residual plot very soon. Let's look at the result first. The result on the left side, right? On the left side. I have already captured the result in the point plot. So let's take a look at the point plot. Which factor should we look at in the report? Which factor? Coefficient, right? Coefficient, very good. Remember the process, coefficient. As you can see here. It's coefficient. Based on the coefficient, we can build the mathematical relationship between dependent variable and the independent variables. Right? Yeah. What kind of relationship can you build? Hours equals to the first value, 1.911 plus 0.055 times incomes, and then plus 0.441 times gym visits. Then minus, very good, yes. The reason is the coefficient is negative now, right? Minus 1.124 times state CA, very good. And then minus 1.370 times state MD. Very good. And so on and so forth, right? Yeah. Very good. Now you can build the mathematical relationship. We just explained the meaning of incomes and gym visits. How can we interpret state CA, state MD, state ND, and so on? What does this mean? Can you see the shorter the state CA is, the shorter the user will use a mobile app? We cannot see that. But how can we explain state CA in our equation? State CA.
People from there use the gym more than.
Use the gym or the mobile app?
Use the mobile app more than.
More than or shorter than? Shorter than, yes.
Oh yeah, sure. Oh, yes.
Very good.
Oh yeah, shorter than.
Very good. Jennifer, do you get it? Do you remember when we build the state CA column? We use 1 to indicate this customer is from California. 0 to represent she's not from California, right? So if suppose we get a new customer, she's from California, what should be the value for state CA? 1, right? 1. You use negative 1.124 times 1. You need to subtract 1.124 from the total hours. If the customer is not from California, we use 0 to indicate she's not from California. 0 times 1.124 equals to 0. We didn't subtract anything. That's why we can make a conclusion that if a customer is from California, she will use the mobile app shorter than any other states, shorter than customers from any other states. How shorter?
1.1.
Yeah, 1.124 hours. Yeah. This is how you explain the meaning of categorical data. Is this important? Very important. If you work for the candidates, you need to look at the difference between states, right? Voters from different states. By doing this, by using the categorical data, you are able to say in which state the candidate is more likely to win, right? If you work for a multi-million-dollar big company, you have several markets in California, in Texas, in Washington State. By using the categorical data, you are able to find out which market is the most important market, which state you should focus on if you have limited resources. This is how you use the categorical data in business analytics. Very important. Categorical data don't measure, but they indicate important information. That's very interesting, actually. I have another question for everyone. It feels like 9 o'clock, but it's just 8. We can pretend it's already 9 o'clock. My next question is, which state used the mobile app longer? Which one used longer? Which state used the mobile app the longest? The longest. ND?
Why?
Okay, very good. Yeah. But that's not the correct answer. I see where you come from. I see your point. But that's not the correct answer. Which state? Customer from which state? use the mobile app the longest?
Yeah, New York.
Which state? In business analytics, they have a buzzword called drill down. Drill down. That means don't be blinded by what you see. You have to analyze the data in depth. Drill down. Drill it down. Don't be blinded by what you see. Some factors you cannot see, but it's influencing the equation. Washington, why?
I have no idea. What you're saying.
Because it's not there.
I was so excited. I saw finally someone.
Maybe it's comparing it with the Washington.
Why?
Because Washington we have not included, so
Yeah.
So whatever the value of the Washington is, it is comparing like Washington has 2, then CA will go negative 1.1 to it's like somewhere around 0.8,
Yeah.
0.8 times of Washington.
Think about the equation this way.
Just one question.
Yes.
All these values are relative to something. It is not the exact value. If I say
Right.
it's minus 1.1, which
Yeah.
means
Yeah.
it is relatively to some other value.
Yeah.
So what is the exact value which we consider so that I can interpret it is minus 1.12 lesser than or greater than some value. So I don't know which value that is, but I'm
Yeah.
trying to understand because in the last statement you said it is shorter than the rest of the states.
Yes.
So my question is if you go by the value, well it's minus 1.69 which is New York,
Yeah.
should be shortest than the rest of the states because it's minus 1.69.
Right. Very good point. If I'm from California, I get a negative number. I subtract some hours from my total usage, right? If I'm from Maryland, I need to subtract some value because the coefficient is negative 1.37. If I'm from North Dakota, I need to subtract some number, right? This is what we can see from this equation. What we didn't see in this equation is the customer from Washington.
Correct.
Yeah. If you are from the 6 states, you need to subtract.
So
That means,
is it like Washington value is being considered as a reference or is it considered?
yes, very good. Very good point. Because we didn't show state Washington in this equation. So state Washington, customer from Washington, is the base level. It's a base category.
Okay.
Yeah.
So it's the value of which could be anything. Because I don't have the coefficient value here. Which
Right.
means the value could be anything. But
Yeah.
relatively, the value of the other states are this.
Actually, you do have a state Washington in this equation. Yes. Yeah. Question?
When we give the value dummy variable 0 and 1,
Yeah.
instead of Washington, if we would have separated, for example, California,
Yeah.
and 6 would have, Washington would have been there in the 6 columns,
Yeah.
the result would have been the same.
The result will be different, but the analysis results will be the same. The conclusion will be the same. The coefficient, if you change the category, the coefficient will be different, but your conclusion will be the same.
Then we can see the Washington time there, and then we will not see the
Yeah,
California.
you will not see one category here. Yeah, if you want to replace Washington, some states in this equation with Washington. Musu said, I don't have a value for state Washington. Is that true?
I agree with the fact that so
You do have a value for state Washington. How can you get the value? As I said, we didn't create the column state Washington, right? But how do we know the customer is from state Washington?
Because if you don't create that,
Yes.
the rest of it.
Yeah. As I said, if we use 1 to indicate a customer is from a state, right?
But there's no coefficient to
Right.
Yeah. Even though we didn't create a column called state Washington, we do have a logical connection. If the customer is from Washington, then all values for all other states should be what?
0.
0, right? 0, yes. 0. Right? Let's say a customer is from Washington. He can get 100,000 as yearly incomes. He visits gym one time a week, right? We get 1.911 plus 5.6, right? We replace incomes with 100,000, right? And then one time gym visit, 441. What is the result? Do we have to, if he's from Washington, do we have to give a value for state CA, state MD? Yes, we do. They are all zeros. We do give the states Washington, state CA, state MD some values, but they are zeros. So they don't influence the final result, right? What is the result here? That's the result. 1, 2, 5, 3, 2, plus 5.6.
6.9.
Yes, very good. 8.952. Not 52. Yeah.
7.
This is how long the user will use the mobile app. If her yearly income is 100,000, if she visits gym one time a week. Let's say we find a similar customer from California. She can get 100,000 as well. She visits gym one time a week. How long she will use the mobile app? She's from California.
So
It's less.
Plug in the numbers, right?
Yes.
Yeah.
Less.
100 as the value for incomes, 1 as gym visits, 1 as the CA, the value for state CA, right? All other states will be 0. Yeah.
So it's 9.
So basically you use 8.52.
7.9.
This is CA. 8.952 minus 1.124 equals to 7.8 hours.
7.95.
It's actually 7.9.
7.915. Which one?
7.95.
Oh, it's
8 and 7.
Here?
No, the up. It's
Here?
7.95.
Oh, 7.19. Okay. 7.952. 7.952. And then here should be
6.8.
6.828. 6.8 hours. Right? Yeah. You can do the same to compare if the customer is from Maryland, from other states. But no matter what, as long as the customer is from Washington, you give 0 to all values
Right.
in the state CA, state MD, state ND, state everything, right? In the equation. Yeah.
But I don't have the coefficient for state WA, isn't it? So how am I going to calculate the exact number of hours?
You don't have to because you choose Washington as the base category. You only look at the incomes and the gym visits. That will be how long the user will use the mobile app if she's from Washington.
So for instance, if I categorize California as the base state,
Right.
would the number of hours I spend, would it be more than when compared to all this?
it will be smaller than the customer who's from Washington.
It will be.
It will be.
If I use it as a base state.
Yes.
Oh, because
It doesn't matter which category you choose as the base category, the conclusion will be the same.
yeah.
The exact number you get from a different category will be different because your state category is different, right? But the conclusion, the comparison conclusion will be the same. Question?
You didn't add Washington because you already knew that was the right answer.
Yes. The reason I didn't use Washington is that if the customer is from Washington, I give 0 to all other states, right? So do I have to create a variable called the state Washington? Not necessary. If I do, I basically make my analysis more complex, right? I already have a way to indicate this customer is from Washington by giving zeros to all 6 categories I have on the equation, right? So I don't have to create the 7th variable called the state WA. I only need to create 6 categories. How do I know this customer is from Washington logically? I give zeros to all these 6 categories I have in this equation. That means this customer is from Washington. Yeah. Also, as you can see in this equation, if I give a 0 to all 6 state categories, the hours will be the longest, right? Will be longest. Will be the longest, right? If I give 0 to all 6 states here, I don't need to subtract anything from the total hours. That means the customer from Washington will be using the mobile app the longest. Yeah.
And the shortest would be, in this case, the shortest would be New York.
That's a very good question. I want to ask you, but you ask me, right? Yes.
Why did you take 5.6 as why did you multiply by?
Teja, let me answer Musu's question first, and then I will move to your question. Yeah. Musu asked me, which one will use the shortest? That's a very good question. We already know customer from Washington will use the mobile apps the longest. Which state will use the mobile apps the shortest?
Yes, New York.
New York?
Yes, because
Relatively,
1.7.9 minus
Yeah.
1.69 is the shortest.
Yeah, very good point. Because if the customer is from New York, we subtract the number, the largest number from the equation, right? As you can see, we subtract 1.7 from the total hours. That means if the customer is from New York,
they use the shortest.
they use the shortest, the mobile app the shortest, yeah, compared to other states. Yeah. From this equation, we can find the customer that use the mobile app the longest and the shortest. Same thing, you can rank the states actually. You compare the coefficients for each state and then rank them. Logically, we know customer from Washington use the mobile app the longest, right? And then the shortest is New York. So we rank them. Washington, New York, the shortest. And then you look at the next smallest coefficient in this equation. Yeah, minus 0.633. The customer is from ND, right? North Dakota. If the customer from North Dakota, we only subtract 0.6 hours. So North Dakota should be the second place, right? North Dakota. And then the third place goes to Texas. If the customer is from Texas, we only subtract 0.7 hours. Texas. Then California? Yes, California. Then then
South
which one?
South-
Maryland, right? South Dakota, yes. South Dakota, and then Maryland, yes. By looking at this, we can see the importance of different markets to our company. Obviously, we need to spend more advertisements, marketing budgets to the market where the customer use the mobile app the longest, right? Oh, you can, yes. That's another marketing strategy. If you want to boost up the market, then you look at the shortest, New York. Yeah. But if you want to keep the customers from the most important market, then you look at Washington. Yes. Yeah. This is how you analyze the categorical data. Any question, Jennifer? Question? Got it? Okay. Very good. George? Good?
I just added the other stages and see what you do.
Okay.
Just change the formula.
Yeah, you can change the categories.
Stages don't do.
Yeah.
Just change
The one we didn't show in the equation is called the base category.
the- right.
You can replace the base category with the categories you can see in this equation.
Or you put all of the stages and it changes it.
Right.
Its own base.
Yes. Yeah. You can use different base state, but the conclusion will be the same. Right? Yeah. Teja, what is your question?
My question was, why did you use 5.6 instead of 0.056? Let me multiply this.
So assume the income was 100.
Why did 5.6?
The income was assumed 100 at that point.
Oh, okay.
That's
Yeah.
why we multiplied that, yeah.
Yeah. Suppose we have a customer. We have a new customer. We want to predict her usage. And then we will ask the questions from this customer. And then we can plug in those numbers to predict how long she will use the app. Yeah. This is how you analyze categorical data. So we talked about coefficient, we talked about p-value, we talked about the R-squared value. We also learned how to analyze categorical data, right? The last step you want to check is residual plots. Let's take a look at the residual plots. Residual plot is just an approach for you to check how robust, how strong your model is. Yeah. There is a requirement for residual plot. A good residual plot, a perfect scenario is residuals must independently and randomly distribute around the value 0. You don't have to draw the residual plot. Yeah, you will get the plot from the software analysis result. Yeah. But make sure that the residual, the plots, as you can see the dots in this chart, must be around the 0 value. And the 0, the good residual plot, the dots in the good residual plot should be around 0, the line of 0. They must be independent. They must be random. Yeah. Let's see some bad residual plots. These are bad examples. As you can see in chart 1, you have a pattern, right? Yeah. The dots on the left side is more intense than the dots on the right side. You have a pattern. In the second chart, you also have a U pattern, right? A U-shaped pattern. In the third chart, in chart C, the dots below 0 are more intense than the dots above 0, right? You have some kind of pattern. And also, chart D, you have a pattern as well. Upside down pattern. What can you get if you can find a pattern in a residual plot? What kind of conclusion can you make if you have a pattern?
The sample percentage of data is good.
If you have a pattern in your residual plot, that means your data are controlled by some uncovered factors, mysterious factors. That means what? Your model didn't consider all the influencing factors. That's why you will have a pattern in the residual plot. Yeah. If your residual plot like this one, randomly and independently distribute around the zero line, that means your residuals are not controlled by some mysterious factors. Your model, the model you just built, fully explain the residual distribution. Yeah. There is no mysterious uncovered factor controlling the residuals of your model. That's why we want residuals to randomly and independently distribute around the zero line. If you find the residuals like this, that means your model is not, it's controlled by some uncovered factors. That means what? If you want to apply the model from a sample to a population, you have to be very cautious. Because in this smaller sample, your model is still controlled by some mysterious unknown factors, right? That means if you predict the model into a population, the unknown factor could influence your model even more. Yeah. That's the information you can get from residual plot charts. Yeah. Basically, you want to look at these four factors: coefficients, p-value, R-squared value, residuals. And then remember the difference between categorical data and the non-categorical data. This is how you analyze linear regression model.
So can we correct this residual, if there is a difference in that with the dummy?
Yes, you can get the residual for dummy variables as well.
No, can we correct this with the dummy, with these patterns?
You cannot correct them. You cannot correct the residual plots. You should get the residual plot automatically from the software analysis. Yeah. But you just raised a very good question. How can I evaluate the residual plot for dummy variable? You can get the dummy variable. You can get the residual plot from the dummy variable as well. For instance, these are examples of residual plot for dummy variables. Dummy variable, because we only have two values, so that's why you can say the values are either 0 or 1. They are around the 0 line, right? Yeah. They are either equals to 0, as you can see here, or 1. For the other dummy, we have either 0 or 1. This is how you evaluate the residual plots.